Hello, friends. Good morning, guys. Hi. 26 participants. Hello.
Hello, sir.
Very good morning.
Good morning, sir.
Good morning, sir.
Very good morning to you all. Done. So far, okay, up to this, I think yesterday we have discussed. Am I right? Okay. So today we shall start with this types of data, that is data types. Okay. And you see here, every variable in C# is associated with the data type. Okay. Data types specify the size. Size in the sense, how many bytes of memory that particular variable is going to consume from your RAM. Because your program is always using the random access memory, which is a temporary in nature. It's called as volatile memory. So as and when current is there, power is there, a RAM holds the content. Once the current goes off, power shuts down, the content of the RAM will be lost because it has got its own nature. Am I right? So therefore, whatever the variable you declare in your program, that is going to consume some amount of memory, random access memory locations. So now integer, how many bytes it is going to consume. Float data type, how many data type it is going to preserve for it. Character data type. So like that, data type specify the size, okay, and the type of the values that can be stored. Okay. So now here, the data types are broadly categorized into three types. One is value types. One more is reference types. Third one is pointer types here. Okay, these are the major data types here. Let us see what is this value type is. Okay, you can read this particular content. When a value of a variable is assigned to another variable, the value is actually copied. Okay, say for example, a is equal to 10. One more, b is equal to, I can assign a. So it means that the content of a is copied into b here. Okay, this is the meaning here, value type. The value will be copied, finish. This means that two identical copies of the values are available in the memory. So A is also holding 10 and B is also holding 10. One more variable, C is equal to A, I can do, or C is equal to B, I can do. So in this sense, all A, B, C are different locations, but the content will be copied into them. So the content of A is copied into B, the content of again A is copied into C. So like that it is. Okay, it's very common. And then the memory is divided into some parts here. One is called as stack. Okay, stack type memory. So it has got some nature, that is last in first out. So it is acting as a stack here. If you go to cafeteria, plates will be put at the bottom first. Next plate, I wash it. Again, I put on the top of that particular plate which has been already kept. One more plate I take, I wash it. Again, I put it on the top of that. Fourth plate I take, I wash it. And then I put on the top here. Then, after only I have 4 plates. Next plate I want to serve. Some candidate comes into a cafeteria, hotel. Topmost plate I take it out and then I serve and give. One more candidate comes. Okay. Again, topmost plate I take it and then I serve it here. So like that, I'm going to keep all the plates from the top end. Again, I'm going to take out the plates from the same end, that is top. So that way, there is a stack available. Hello. ಏನಾಯ್ತಪ್ಪ ಅಡ್ಮಿಟ್ ಮಾಡ್ಕೊಳ್ಳಿ ಆಲ್
ಫಿಟ್ಟಿಂಗ್ ಆಗಿಲ್ಲ
ಆಗೈತಿಲ್ಲಪ್ಪ ಕರೆಕ್ಟಾ
ಈಚೆ ಕಡೆ ಚೋತು ಬಿದ್ದಂಗ ಆಗೈತಿ
ಯಾರು ಮಾತಾಡ್ತಾರೆ
ಫೋಟೋ ಇಡ್ಲೇನಾ
ಹಲೋ
Hello, sir.
ಯಾವ ಹುಡುಗಿ ಮಾತಾಡೈತೆ ಅಲ್ಲಿ ಎಲ್ಲರೂ अडमिट आदरला
सर केतन कॉल करायला बघा त्याला ऍडमिट करा आत.
आत केलं की किती वेळ करायचं रे बाबा
तेव्हा कॉल केला ऍडमिट करायला म्हणून.
सगळेच ऍडमिट केलं बघा सगळ्यांना ऍडमिट
हा
केलेलं
सर.
झालं का विचार त्याला
हॅलो सर. हा नाही सर मेसेज केला घ्या केलं की म्हणून.
बर So like that here, some portion. One is stack. There are no other one is heap here. Heap. One more area. And one in some of the portion of RAM, operating
Sir,
system is stored.
सर ते पीडीएफ सेंड करा की सेकंड युनिटचं याला गुगल याला क्लासरूमला.
गुगल क्लासरूम नाही रे आता ते घे ते कर हे कर सगळं करत कुठं बसायचं रे गुगल
सर
म्हटलं
पीडीएफ
ते वर्ड पाठवलं की
सोडा हो कुठं पण सोडा
नाही व्हॉट्सअप
चालते व्हॉट्सअपला सोडा सर.
व्हॉट्सअप सोड रे काल सोडलं की कुठं आहेस तू परवा दिवशी सोडलं बघ बघ जरा व्हॉट्सअप मध्ये हा डॉक्युमेंट आहे सगळं असते तिथं सोडलेलं असते ते हा तर नीट बघ जरा these are stored in stack ठीक है and one more thing here again two types one is predefined types one more is user defined types so all these are considered value types all these variables are going to consume a memory of stack okay. One is predefined type, the other one is user-defined type. User in this is the programmer. Predefined in this is these data types are available, comes with the C# compiler. Is it right? This comes with C# compiler. And making use of these simple or predefined data types, I can define my own data types. So that is called as user-defined type. Program can define his own data types. So let us see what is this predefined data types. Okay. Here numeric data types, one more character, the other one is Boolean type. Okay, so one by one we'll see what is this numeric, that is integral value types. It may be a signed or unsigned, or in numeric it may be a floating point. Last time I think we have discussed all this. Same thing continues here. One more is decimal. Is it right? So we'll discuss about this in subsequent classes here. Data types falls under numeric. One is integer, one more is another one is floating point, one more special data type available, that is decimal here. And after this numeric, character data types. Character. Similarly, Boolean. This is one more special data type where I can store only two values, either true or false. So like that, these comes under built-in data types here. Built-in in this is predefined data types. One more user types, that is enumerators. We rarely use this enumerator. The structure, making use of all these data types here, I can combine and I can define my own structure. So structure consisting of multiple data types together wrapped up into one entity. Okay. That's called as structure here. And about this structure enumerator, we are not using anymore. Am I right? Maybe I think in C programming you have used structure. Structure we use for linked list and all. We used to use that structures, different data types. So now let's see what is this reference types here. So reference types in the sense when an assignment between two reference variable occur, only the reference is copied. Okay, the actual value remains in the same memory location. This means that there are two references to a single value. So only one location I have. Okay, only one location I have. Say suppose a is equal to 10. B is another variable. I can refer that B to location A. It means that both A and B are the variables pointing to the same location. So only one location of RAM having two names. Yesterday I told you, my name is Shidanand. I'll be called with some other name, my nickname. Okay, one person having two names. One location having two or three or more names here I can give. Okay, if A is equal to 10 I do, and if I refer B to A, it means that both A and B are referring to the same location. If I alter the content of A is equal to 20, it means that the content of B is also changed here because they are pointing to the same location. So this is also one more data type. It will be useful for swapping. When you are swapping some memory location, these reference data types are used here. Okay, we shall see that sample program that's called as for swapping. Without reference, what happened? Does swapping take place or not? With reference, does that swapping takes place or not? We can see with some simple program later on. So this is our reference data type. Only one location have got more than one names here. This means that there are two references to a single value. Okay. And these reference data types are stored or occupied in heap portion of RAM. Heap portion of RAM. RAM is divided. One is stack. The other area is heap memory. So stack memory is used for these value data types. Value data types in the sense your integer, character, float, whatever it is, or it may be a structure enumerator. Okay, these are defined by user defined data types, and integer, character, float, all these are comes under predefined simple data types, built-in data types. Making use of these built-in data types, I can define my own new data types such as enumerator structures. Okay, and these occupy stack portion of RAM here. And reference variable will be assigned automatically taken care by compiler to be preserved in heap portion of RAM. Okay, no need to discuss much about what is stack, what is heap, how they work, will be managed by compiler, nothing. It is beyond the scope of the syllabus here. We have to understand that RAM is being divided into some portions here. One is stack, where data value types are stored. And the other one is heap memory, where reference data types are preserved. One more portion is available in RAM also to store some Office, OS operating system. Operating system will be loaded. Once you switch on your computer, operating system is stored inside hard disk, and that has to be brought into RAM here. Unless and until operating system is brought from hard disk to the RAM here, your computer will not function here. That's called as booting process. The process of loading operating system from hard disk to RAM is basically called as or termed as a booting process here. Therefore, your computer takes some time initially. Is it right? Therefore, this is what reference type is all about. Again, in that reference type, I can divide into predefined type. That is simple type. And one more is user type. So what are the examples of predefined? That is objects and strings here. So therefore, especially in C#, it is object-oriented programming. Therefore, all these objects we create from the class are belong to this reference type here. And that is going to be stored inside the heap portion of a RAM here. Similarly, user-defined types comes under this classes. Okay, classes. Once I create class, then I create objects here. Similarly, arrays. Arrays also comes under reference here. Okay, only one name is given to the complete array here. A of 10. All 10 locations are having the same name, A here. They are referring. All 10 locations are referred by only one name, that is A here. A of 0, A of 1, so like that here. And then delegates and interfaces about this we'll be discussing in the unit number 2 only at an end here. Tail end of this unit here, we'll be discussing about operator overloading. What is delegate? What is interface? All these things will come across. All this falls under this reference type here. Question won't be asked here. 5 marks question might be asked here. Define the data type and then explain the types. So this is what the table, if you write here, it will give fetch you 5 marks, no doubt in it. Okay, some information you write down, and especially you have to punch here, stack and then heap here, and then predefined, user defined, predefined, user defined. Some examples here, this side. One more is pointer type holds the address of the another variable of similar data type. So pointers, I think Java, it is not using pointers. C, you use pointers here. Okay, pointer in the sense it is a special data variable which holds the address of a memory location. Address, because as I told you, random access memory is consisting of memory locations, and every location is identified by some hexadecimal address. Okay, that address can be pointed or stored into spatial data type, that's called as pointer data type. Remember, pointer data types holds the address of RAM. Okay, address. Ordinary or int A, I cannot store A. I cannot store in A the address of memory location. It doesn't have any capability in it. Whereas if I declare int star A, star in this is A is not an ordinary integer, but it is a star, that is pointer variable which can hold the address of memory location of integer data type. Okay. So like that, data types can be divided into 3 types here. One is value type, the other one is reference type, the one is pointer types here. So this is how data types are categorized broadly in C#. Now let us see 1 or 2 examples of this. What is value type in that numerical types? Okay, what are the size of them? Okay, how much bytes in each memory type is going to consume? Similarly, it is unsigned integer, unsigned integer. Okay, and their keywords we shall discuss. How we can use that signed integer? What is the keyword I use? And what are the keywords used for unsigned integer data type? And how many bytes it's going to consume? That is size of that particular data type. And what is the maximum value it can store and minimum value it can preserve in that particular location? So depending on the bytes here, this minimum and maximum can be calculated. You need not to remember all these things. 1 or 2 simple things you can remember. Then no need to remember all this size here. You can simply calculate if it is required. Okay, I'll discuss how to calculate that. We'll check it out. So in value types here, we have to see integral, that is integer type, one and the same. Integral and integer, one and the same here. One is signed, the other one is unsigned number. So number may be signed number, 5. It is an unsigned number, unsigned number. Whereas -5, if I say here, it is signed number. Let's see. Other data type, that is floating data type. So what are the basic types of that float data type? And their corresponding size and their maximum and minimum value it can store in that particular location. One more is decimal data type. So all these 3 things here, one is integer, floating point, decimal, and then character type, Boolean type. These are basically comes under this. So we are discussing this part now in detail. Is it right? And in 5 mark question, this is enough. If they ask you 10 marks question, all these things, numerical, size, simple things, simply you have to, explain it here. Is it right? So in this here, signed, unsigned, decimal, character, Boolean, we shall discuss here. Let's see value type, that is signed integer. Yes byte. Yes stand for signed byte, which should be small s. Small s. Okay. Keywords always written in small case. Done. Okay. So one is byte. Byte in this is basically it is going to consume 8 bits. 8 bits. So signed in the sense the most significant bit, this side, left hand side. Okay. So that bit is preserved for sign. If I write in that particular MSB 0, it shows that it is a positive number. If I write 1 here, the remaining bits will be considered as negative. So number system, I think you have studied in first semester. That is what you have to understand here. I cannot explain everything here, how that is converted, what is the MSB, what is the LSB. Okay, you are final year students. LSB long form yara pyar ಹೇಳ್ತಾರಪ್ಪ? Can anybody tell me what is the long form of LSB? Guys, are you there or not? Hello. अरे कोई है?
Hi sir. Yes sir.
हाँ,
Yes,
LS पे लॉन्ग फॉर्म कह रहे?
हाँ
LS पे लॉन्ग फॉर्म का है? हाँ, हे अंकित है.
लेफ्ट शिफ्ट बाईट.
हाँ?
लेफ्ट शिफ्ट बाईट.
कुठला काय रे बाबा तू? एक मिनिट थांब रे बाबा. हॅलो थांब एक मिनिट. त्याला अनिकेत एक मिनिट. आय बी बॅक 1 सेकंड. ಎಲ್ಲಿದೆ ನಿಂಗೆ?
केत्या
हॅलो. हॅलो गाइस.
Yes sir.
हाँ सर.
So LSB in the sense is significant bit.
Least
Least
significant.
significant bit.
MSB stands for most significant bit.
Most significant bit.
Done. So LSB, it is available at the left hand side of your RAM. If you draw a RAM here, square box you write, okay, rectangular, square, vertical box you write, and you have to draw one horizontal line, and then you have to divide it some amount of bits here, 8 bit, one choke debut ಮಾಡಬೇಕು ಅವಾಗ ಗೊತ್ತಾಗ್ತದೆ. So left hand side, that's called as the bit which is present at the least side, left hand side, the least significant bit. That consisting less magnitude. So 2 raised to 0. Next, you have to go towards left hand side. Okay, then the power increase 2 raised to 1, and then 2 raised to 2, 2 raised to 3, 2 raised to 4. So like that it goes here. So from this side to this side, it travels here. Is it right? This is called, suppose this is locations are right here. So what happened? This is least significant bit. This consisting 2 raised to 0. Second, 2 raised to 1, 2 raised to 3, 2 raised to 4. So like it goes here. This side, this is called as MSB, whereas this is called as least significant bit. This is called as most significant bit. So like that, byte is reserving some memory location, and so byte. It is going to take 1 byte of memory, in the sense 8 bits. So in that, most significant bit is written as signed here, in the sense MSB. So this side, this one cell is reserved for showing. If I write here 0, then that is indicating that the remaining values will be positive. If I write here 1 in this location, so this value is what? Positive. So like that, yes byte, it is going to take 1 byte of memory. Then what is the minimum value I can store and maximum value? So let us see what is the maximum value first here. So 2 raised to 8, in the sense 128 minus 1, that is equal to 127. So now here I have to write it as 2 raised to 7 it is actually. Okay, 2 raised to 7 agutave. Yakandre the bit for most significant is used for sign here. S stands for sign. So therefore it should be 2 raised to 7. I have to make a modification here. Done. So 2 raised to 7 ಆಗ್ತೈತಿ 128 ಆಗ್ತೈತಿ minus 1 you have to do, because 0 is also a number. 0 is also a number that I have to minus here. So this is the maximum value I can store. If I write here 2 raised to 0 plus 2 raised to 1 plus 2 raised to 3, 2 raised to 4, you have to add everything. 2 raised to 0, 1, 2, 3, 4, 5. Okay, up to here 5, 6, and 7. Only this much. So this, if I write here 1, 1, 1, 1 all over, it will be 128 minus 1 you have to do, because 0 is one more number. And 0 you have to reduce it. This is the maximum number I can show, 127. Similarly, minus 7 mark. 7. Okay, that is 128 only. Okay, this is represented as a 2's complement number. So I represent negative numbers as a 2's complement. Okay, 1's complement, 2's complement, I think you have studied in your first year or second year. So that number system is very useful in understanding. Here not required. You will not much worry about it here. So S byte is consuming 1 byte, and the most significant bit is for sign. Therefore, 1 bit is gone. 2 raised to 7 only. Okay. Similarly, short is going to consume 2 bytes of memory. 2 bytes in the sense 2 raised to 16, because 1 bit is having 8 bits. So 2 bytes in the sense 2 raised to 16. So therefore, this will be this much, minus 1 I have to do. Minus 1, because for 0 it is. So this is the maximum number I can store. Okay. Similarly, int is going to consume 4 bytes of memory. Okay. That is 2 raised to 13 minus 1. If you calculate, that value comes here. Okay. Minus 1 you have to do. So 8 bytes in the sense 8 into 4, 32. So that is what I write here, 2 raised to 32. This is the maximum value I can store in the integer data type. Similarly, long is going to consume 8 bytes of memory. 8 bytes are reserved for one variable. If I write long A, so A is pointing to a location, not only for 1 byte, it is going to be reserved 8 bytes all the way for long A. If I write long A, long is consuming 8 bytes of memory. All 8 bytes are reserved for that value here. The maximum I can store is 2 raised to 64 minus 1. Am I correct? But this here, you no need to do minus 1 here. Okay, you can calculate on the piece of paper what is the logic. Let us say, I think you need not to remember everything. All this not required. At least this you remember. Int, this much you remember. Sufficient. Okay. And how many bytes each data types are going to consume. Try to remember. Similarly, unsigned. Unsigned in the sense the most significant bit is not reserved for indicating sign here. Similarly, example of this unsigned integer is byte. Okay. Unsigned short, unsigned int, unsigned long. U stand for unsigned here. Only byte changes it. Byte here it is signed byte. That's it. Byte I will not write here U here. Byte is automatically it is unsigned. So this is going to consume 1 bytes of memory. And the most significant bit is also used. Therefore, it is 2 raised to 8. Here it is 2 raised to 7. Now it is 2 raised to 8. All bits are used. No most significant bit is not used for indicating sign here. Unsigned bits. All numbers I can store. Only positive numbers I can store here. Therefore, the negative number is 0, 0, 0, 0 here. I can, because most significant bit is not at all used for indicating sign. There is no sign question of sign here. Everything is positive. So right from this is my first location. Okay, 1, 1, 1, 1, 1. All over 8 things. If I write here, it is how much? 255. 2 raised to 8 is 255. Similarly, unsigned short. Short was going to take 2 bytes, but here it is 2 raised to 16. Now it is 2 raised to 15. Here it should be 2 raised to 15. Anyway, you just do it here. 2 bytes. 2 bytes in the sense 2 raised to 16. Here it is 2 raised to 15. 1 second. 2 raised to 15 it is. Sure. Because most significant bit is used for sign here. This is correct. 2 raised to 16 is 65,535. You can calculate. I think everybody is admitted, right? How many students are there, man? Only 45 students. Strength is, I think, 150, I think.
139. 139.
39 फक्त 39 दुसरी कुठे गेलो झालं काय रे टाइम आमचा अजून 10 मिनिट आहे की रे दिस मीटिंग विल एंड इन 10 minutes. Okay, done guys, huh? So now you can note here all integers by default are integer type. In order to make them other integer type, the value must take append with the character U, L, everything. Okay. This I think we skip it here, time being, not required. Okay, sure. Floating point. Floating point is this is integer types can hold whole numbers, and therefore we use another type that is called as floating point number. Okay. Float. Float is a data type, comes under this floating point. We can store some fraction. It is going to consume 4 bytes of memory, that is 2 raised to 32. Okay, 8 4s are 32. So 2 raised to 32 minus 1 is the maximum number. Minimum number is no minus, minus 2 raised to 32. Finish. So it is minus, it is plus. Similarly, double is one more data type available here. If I write double A, so that A is going to consume 8 bytes of memory. Then what is the maximum value I can store is 2 raised to 64. That is 8 into 8. 8 into 8 is 64 minus 1. Minus 2 raised to 64. So this table I think you can remember easily. Whichever you feel good, comfortable, you just try to remember. If you get confused here, but if you be familiar with all this also you can easily remember 1 or 2 tables. Similarly, the float point are single precision numbers with 7 digits. The double type represent double precision with 15 divided by 16 digits. So precision in this is how many digits you want after decimal point. 23.69444. So precision is only 4 digits. I can extend it by default. The precision value is how much? 7 digits. Up to 7 digits by default, it will be displayed on the screen. If I want to extend that precision after point, how many values I want, I can extend it here up to 15 digits to 16 digits here by making double precision. Okay. Double precision here. So floating point number by default as a double precision. To force them to be a single precision, we must append F or small f or capital F to the number. Okay. These are examples here. And this way. Capital L or L is being preceded here. Similarly, U is to make it unsigned. In the same way, precision, if you want to increase here, I simply follow F for capital F or small f here. Okay. This I think you should not much worry about. Only thing you have to remember the data types and small amount of, some portion of table you have to remember. Float, 4 data types. Okay, double 8 data types. Integer 4 bytes. What is the maximum, minimum? So at least integer, float, double, character. You simply remember, and this decimal also you try to remember. Finish. So character. So how much? So it is going to consume 16 bytes of memory here. 16 bytes of it. So decimal is going to consume how much? 16 bytes of memory. So it is a high precision double data type. Okay, designed for the use of financial monetary calculations. So for big numbers, okay, the big numbers comes under financial management. So therefore, I cannot store the big number into integer type or float type. So for that to store big number, okay, I use one special data type that's called as decimal because it is going to reserve 16 bytes of memory. So 2 raised to 16 into 8 133. 132. How much? 16 into 8 कितना होता है? 128 I think. 2 raised to 128. That is a number here I can store into this. Big number I can store. So this is how integer, float and okay. Now similarly, let us complete this character type. In order to store a single character in the memory, this type is used. Single character. The character consumes the size of 2 bytes, but in fact, it can hold any single character here. It has been designed to hold 16-bit Unicode character in which 8-bit code is subset. Okay, to 16-bit it is going to take. Any character you can represent here. Okay. Similarly, Boolean type. Boolean type is declared by the word bool. It has only 2 values, true and false, and it uses only 1 bit of storage. 1 bit it is. 0, it shows that it is not byte, it is only bit. If I write 0, it is false. If I put 1 in that particular cell here, it shows that false. True. Finish. So we cannot use 0 or false, 1 or true, 1 for true. Here we can use in C, but in C#, we cannot use that. Boolean values are often used to test a particular condition during the execution of program in selection iteration statements. So this statement, selection and iteration statement, will be seeing that here. If statement is the selection statement. iteration statement, for loop, for, do while. All this comes under iterations. We'll be discussing about these statements here in the next class. So like that here, a reference type is also one. There are divided into two types. One is predefined type, the other one is user-defined data type. A predefined, that is object and strings, and then in complex or the user-defined is classes, delegates, and interfaces. The same thing is written here. Here, whatever in table, if you remember, this is what it is written here. Simple. Is it right? This you need not to worry about it. We are not worried about the data. Bytes it is going to consume, because everything is created from the remaining data types only. Okay. So this ends your data types. Okay. Tomorrow we shall see with the decision making. So I have already shared this document with you. You can just go through that. Okay. So you can take a printout. I think time is up. I think time up by guys. Huh? What is the time now? Time 12:20.
12.
Okay. We shall close today. Huh? Guys.
Yes, sir.
Good
Okay,
day.
sir.
Okay.
Yes,
Bye.
sir.
Done. Have a great
Bye,
day.
sir.